Okay, here we go. This is 2.1 real numbers. This is for Algebra 1. Alright, let's get started. First thing here we have set notation. Set notation is just going to look like these. I'm really not good at making these brackets, but I'll do my best. It's looks like this, and I'm really bad at doing it on this side. There we go. So it's just a set of brackets. And it just represents a set of numbers. Okay, so we could have something like, doesn't really even matter, just a set of numbers. Okay, so they're just in those brackets like that. Alright, now we're looking at some real numbers. So we're taking a look at numbers and the difference between some of these. So just kind of a little brief history on numbers here, I guess. So our natural numbers, were just our numbers used to represent things that we use, right? Like when we first started using numbers, it might be, I have one goat and you have 2 chickens, something like that, right? So our natural numbers are just 1, 2, 3, 4, and that goes on forever, right? Alright, and then whole numbers, this was a big discovery in math, was the idea of 0, right? What about the person who doesn't have any goats or chickens, right? So the only difference here is that 0 is included here. Alright, but then it just goes 1, 2, 3, 4, and just keeps on going. Okay? And then integers, alright? Integers also represent, if you borrow 2 chickens, right, how do we represent a debt, right? So now we have to bring in negative numbers. Okay, so now we've got going all the way to negative infinity, right? And we got -3, -2, -1, getting up to 0, and then we get into our positive numbers, okay? And that will go on to positive infinity, right? Okay, so that stuff should be pretty easy for us. The next part here is a little tricky for some students. We've got rational numbers and irrational numbers. So one way we can differentiate between the two of those would be rational numbers can be expressed as fractions. So we can write that down. Can be expressed as a fraction. Okay, and you know what, I'm pretty bad at writing on this. I'm just going to enter in some text here. So for irrational, it cannot be expressed as a fraction. Okay, makes sense. Alright, so I'm going to go ahead and just get this a little bit smaller. There we go. So, irrational numbers can be expressed as fractions. Irrational numbers cannot be expressed as fractions. Okay? So if you have a fraction, no matter how weird it looks, it is a rational number. If you cannot write it as a fraction, it is irrational. Okay? Kind of like this square root of 2. That's not a fraction, right? So that would be irrational. Alright, so we're going to get a couple more ways to determine if it's a irrational or rational numbers. Okay, and I am going to switch on over to a different view because I want you guys to see my calculator for this. Alright, so another way to look at this is rational numbers terminate, and what we mean by that is if I were to convert this -1/8 into a decimal, I can do that 2 ways. I can do -1 divided by 8, right? Divide the numerator by the denominator, and I get -0.125. Okay? And then it terminates, right? It ends. It doesn't keep going. It just stops after 5. Okay? And I'm going to show you one other way, just because I didn't get a chance to show you guys this last week. I do want to show you guys this n over d key. That's here. That's your fraction key. You're probably going to be able to use that a lot this year. So I'm going to do negative, hit the fraction button, or that n over d key. Just do 1 over 8. And then in the corner here, you have these arrows going in the opposite directions. If you do that, oh, sorry. Gotta clear that. I'm going to press enter first, and that will reduce your fraction. Oops, you can't even see that. That's going to reduce your fraction. So 1/8 is already reduced. But then if you hit these double arrow keys, it's going to give you like the alternate answer. So if I have the decimal, it will give you the fraction, and if you have the fraction, it'll give you the decimal equivalent. Okay? So that is definitely a key that we're going to want to know and use all year. Okay? Alright, back to rational numbers. So these numbers, right? Negative 1/8 converts to negative 0.125, and it terminates. Okay? Or it ends, right? That's what terminate means. It means it ends. If you get terminated at your job, you are no longer employed, right? Your employment is over. Okay? So if it terminates, it's a rational number. Or, let's try, can we see this? 16 over 11. That's 16 over 1, sorry, over 11. And we get 1.45454545. So this is really 1.45, and this 45 is going to keep going. So you probably remember this from middle school. If you have a repeating decimal, we just put the line over what repeats, and that indicates that is just a repeating decimal. Okay, so if it terminates or if it is repeating, it is a rational number. Okay? Now, if it does not terminate, or so if it doesn't terminate, when it does not repeat, so non-terminating or non-repeating, I'll write those down, non-terminating or non-repeating, these would be irrational numbers, right? So I think we all know that pi is, 3.14 ... and we know that pi never ends, right? Okay, but also something like square root of 2 never really ends. So if I go ahead over to my calculator, and if I want to type something into my little square root symbol, or my radicand, that is this green symbol right here. Okay, so to get to that, I have to hit the second key, and then I have my little square root symbol. Okay, so now I can press 2 and then enter, and now it's going to spit out, oh, this is already reduced down to the smallest form, right, the simplest radical form. So again, I want to hit this double arrow key to get the alternate answer, or the decimal equivalent. Alright, and so this we get, I don't know, what is that, 1.41421356, and that's going to keep going. That doesn't end at 2, that's just going to keep on going. So those are both examples of irrational numbers because they are non-terminating and they are non-repeating. Okay? So let's take a look at some of these example problems. So we're going to label these. Alright. So we have 5. Okay, so 5 is just the whole number 5, right? So if it's whole, then it's also definitely going to be an integer, and it's going to be rational. Right? Now you might think, well, can 5 be expressed as a fraction? Sure, 5 can be represented as 5 over 1. Any number can be written as a fraction over 1. Okay? How about 0.6? 0.6, is that a whole number? No, a whole number has to be whole, like 1, 2, 3. Is it an integer? So an integer, the only difference between an integer and a whole number is an integer could also be negative. Okay, so it is not an integer, but is it rational? Could I express that as a fraction? Sure, this is 6/10, right? So this could be expressed like that. Okay, also as a decimal, it terminates. It's just 0.6. Okay, so that is a rational number. All right, moving on. Is negative 24, is that a whole number? Okay, well, if we remember, whole numbers are 0 through infinity, but they do not include negatives. What includes negatives? Integers. So it is an integer, and if it's an integer, it is rational. Right? We could express that as a fraction. It would just be negative 24 over 1. All right, moving on. 9/7. Is it a whole number? No. Is it an integer? No, an integer is just a negative or a positive whole number, so it is not that. But is it a fraction? Yep. It's an improper fraction, but it's a fraction nonetheless, so that is rational. All right, and the square root of 11. So let's type that in. Let's get out our calculator. Let's hit the second key and get that Radican. Type in 11, press enter. It's going to spit out the same thing. So then I go and I hit this double arrow key, and I get 3.31662479 ... That's going to keep on going forever. So that's definitely not whole. It's definitely not an integer. Not rational. That is irrational because it does not terminate or repeat. All right. Next one, we've got a whole. Is this a whole? We got a decimal, so it's definitely not whole or an integer. Is it rational? Yep. We mentioned that if it's repeating, right, that's what that line on top means. If it's repeating, it is a rational number. So this is just rational. Okay? All right, is this a whole number? Definitely not, because it has a fraction. Definitely not an integer. But it is a fraction, right? We could represent this as an improper fraction. All we would have to do is 2 times 3, add 2, and we're left with 8 over 3. Okay? So that is rational. Okay? I think that is a good spot to be done for today. Why don't you guys give problems 1 through 12 a shot.